Welcome to the July 2022 Planetarium Zoom seminar. Today, we have Jeff Neve from the Museum and Informal Education Alliance at JPL, and he's going to do the topic of the art of Mars, activities for planetariums and others.
Thanks, Alan. Well, welcome everybody. Thanks for joining me today. We're just going to get started right away. The show that I made was called The Art of Mars. And for any Sun Tzu fans out there, you might get the little reference. The reason I made this is because Alan had actually asked me to update a very classic planetarium activity called Red Planet Mars. And it's about just exploring Mars and doing a little bit of sketching, and there's a little bit of astrobiology in there as well. If you've never heard of it, you can go check it out. It's called the Planetarium Activities for Student Success. And before I go on, I should mention the disclaimer of I do work at JPL, I do work for NASA, but I'm here on my day off. Okay, so I'm not here representing NASA or JPL in any way, and the opinions I express are totally my own. And I'm just going to start sharing. So this is kind of the starting screen. The whole show comes with an entire packet of media that you can import into any digital dome system. And you can also even use it for flat media as well. So you don't even need a dome to do this. And I think it's a great classroom activity as well. So I'm just going to hit play. And I'm just going to kind of talk over it. I'm not going to teach it the way I would to an actual classroom of kids. Hopefully you'll appreciate that, but there is a whole written script that I put together in case you wanted to kind of see what I would say during all of these. So
Can you pause that for a second?
Yeah.
Because there's a question that probably is appropriate right now. Is this the control panel for the spacecraft to Mars?
Oh, Adrian, no, this is the control panel for the show, for the planetarium show. So if you don't use a planetarium, you could ignore all the buttons. But if you do have a planetarium, hopefully you have something like this where you have a page or something, some sort of interface where you can press different buttons to do different things on the dome. And this is just personal preference, but the way that I lay mine out is that I've programmed dozens and dozens of optional buttons and random access buttons. But for new presenters, especially, I make sure to make a single column, just the first column of buttons that should get anybody through a show without too much issue. And you just start at the top and you go straight to the bottom and you just work through it that way. All right, so the really important part is just the big giant circle just at the bottom left, okay? And again, if it doesn't make sense to you, if you're not a planetarian, it won't make sense to you. But hopefully the visuals can kind of help you out. Okay. All right. So here I'm just setting it up, and we're just starting at noon. And actually, I've set the date. It's right before the Perseverance rover launched. So that's the date that I just happened to choose. And then we talk about how art and science in formal classrooms is very separated. You know, you go to art class and then you pack up and then you go to science class. But the whole point of the show is, what if art and science weren't separate? What if you could integrate them into an activity? And that's what we've done here. And so it's July 30th is the date you can see. And the first activity is to find Mars, to actually find Mars. And so what I'm going to do is I'm going to show you a couple pictures. I'm going to pause it here because these are just two pictures that people have taken of what Mars really looks like in the night sky. And so here's how you talk about how Mars, it looks like a red star, right? Even though it's not a star, it's a planet, it looks red. And so now the challenge for kids is to actually look around the sky and find Mars. See if you can find it. Can you find a red dot? And people will pick all sorts of red dots. And the concept is that we're just going to find Mars by traveling through time. And so now you can see down here, I have a little button that says go to 731. So we just jumped one day ahead. Now in the original planetarium show, the original planetarium activity, you had to jump like, what was it, Alan? Like 1 or 2 weeks, I think?
3 weeks.
3 weeks, yeah, 3 weeks. And I suspect, I don't know for sure, obviously, but I suspect it's because in the old analog planetariums, you could really only flip that switch and you didn't have very precise control of the annual motion of Mars. But in a digital system, you can have very, very precise control. So I've actually jumped a little bit less than 1 day, or and so you probably didn't see it. A, because the screen is super, super small, you can't see it. But it's really interesting that in this system, I'm able to actually program a jump back and forth over and over and over. Now, take a look. Can you see it move? No, it's probably still too small. But this is the technique that we call blink comparator, right, in astronomy. So we can talk a little bit about that with the kids, and then we'll just label it. And you can see it's ever so slightly moving. I've labeled it now. Can you see it now? Thumbs up if you can see it. And obviously, if you do it in the dome, you'll be able to see it move. And I should pause right here and mention that if you do have one of these dark matter systems, I also programmed in a 1 week jump. So not just 1 day, but 1 week. And if you jump 1 week, if you jump back and forth 1 week, you can actually see Jupiter and Saturn move in the sky. And so once we've found Mars, we can start to explore Mars in a way exactly like our ancestors did. So when ancient humans first saw Mars, they didn't really know what it was. In fact, the word planet comes from the word planetes, which is Greek for wanderer. As they saw it wander, all different cultures everywhere started giving it a lot of different significance in their mythologies and in their lives and in their art as well. And so this next button, I've chosen a couple of items that kind of demonstrate the ancient art of Mars. And so on the left, of course, is a sculpture, is a Roman sculpture of the Mars's namesake, of the Roman god of war. But in the middle, there's the oldest star map ever found. I got that from the British Library, and it's a Chinese star map. Go figure. And in Chinese, they call it 火星, which means fire star. And so there's a whole text about that too. And then I did find a reference to the Hindu god Mangala, and I actually did contact the Hindu Foundation of America just to double check that the Wikipedia article was accurate. And they were like, yeah, it's pretty accurate. So they said I could use it. And it's just, again, it's an example of how human beings have interacted with Mars, have explored Mars through art. This segues into after the invention of the telescope, then we really started cooking, right? Astronomically speaking. So I'm going to pause right here and kind of go through from left to right. So I have Galileo sketches right there from 1600s. I have William Herschel's from the 1700s, Percival Lowell's in the center there, and then that one actually, I don't know where you got those from, Alan. Those sketches that says photo and sketch comparisons, they came from the original Red Planet Mars. So I'm not sure where you got those, but I use them anyway because they're cool. And so it kind of shows you that the point is that even after the telescope was invented, and even after photography was invented, sketching was still really important in astronomy. Astronomers still took out their sketch pads, looked through a telescope, and actually sketched out what they were seeing for a lot of reasons. One of them I'm sure is cost, because photographic plates are expensive and sketching costs you nothing, right? Another thing is accuracy, though. There's a nice activity in the original show that kind of simulates what a fuzzy Mars will look like, because the atmosphere is not stable, because a whole bunch of different factors can mess with your view of Mars. But if you watch and look and really look with your eyes and sketch, you can see and come out with much more detail. And this is where you can also mention the whole story of the canals on Mars that Percival Lowell said he saw. My personal favorite, my personal addition to this one is the very, very far right picture. It's a sketch of the very first television image of Mars. Even when we sent a robot to Mars, sketching was still important. And the story goes, I don't know how apocryphal this is, but the story goes that they just couldn't wait. The scientists just couldn't wait for the image to be processed by the computer. Mariner 4 was in 1965, and it went over there, it took the picture, and then the data came back, the ones and zeros came back. And the story goes that the scientists just couldn't wait to see what they had gotten. And so they printed out the ones and zeros on strips of paper and they stacked them right up next to each other and they did a colors by number uh, picture and they just shaded it in. And that is the picture that they got. And so, yeah, and there's a whole link in the script about if you want to read about the whole story. So, all
Hey,
right,
Jeff.
so yeah, go ahead.
By the way, the sketches that you were talking about before, I think those are Lowell sketches, aren't
Yeah,
as I recall. So that's where they came from.
great.
Someone is asking if you can make that lower left image bigger.
Well, I can't because this is just a video, but if
Oh,
you,
it's a video. Okay.
yeah, this is just a video, but um, I did send you the link. Let me paste the link one more time for anyone who came late. So this is the link to the actual video, and you can actually zoom in up as much as you want. And us, of course, in the actual media packet, the real pictures are individually packaged in there, so you can look at them yourself to your full content. Okay. So after Mariner 4, then we
Excuse
started
me.
sending all sorts of
Excuse me,
yeah, go
Jeffrey.
ahead.
Hi,
Go
it's
ahead.
Roseanne.
Hi, Roseanne.
Hi, honey. Even if you click on this, it's still too small.
Oh, yeah, no worries, Roseanne.
So
Here's what I'm going to
I
do.
know, but is there a way that somehow I want to see the images that you're talking about?
Yeah, absolutely. Here's what I'm going to do then. Okay, what I'm going to do is I'm going to pause. This is actually a good chance to pause because this is actually where I would pause in the show, actually, because once you have this, what I've built is I've built a little timeline all around the dome, of the different Mars missions. And of course, I've kept the ancient Mars and stuff up there as well. So you have an entire history timeline of humanity's artistic interactions with Mars. And this is actually where I would pause for people to take a look around, ask any questions about any Mars missions. And so this is actually very appropriate. So thank you, Roseanne, for that little segue. So I'm going to pause for a second, and I'm going to grab the link for Roseanne to the actual slide deck. So I have a flat slide deck that has actually all the media sources. So you're welcome to take a look. All right. Any other questions while I'm grabbing that link?
Yeah, I'm wondering, this is Sally. Hi, thank you.
Hi.
So right now what I see is the very small image in my corner. I know that I could probably put it on a flat screen for students to see, but it's really just watching right now, or questions and answers. What I want to know is if there's a way to make it more of an interactive STEAM program where, do you have any lesson plans or activities where you say, okay, now you sketch your own idea what Mars would look like, or what people thought Mars looked like at a certain point in time?
Excellent question, and thank you for the segue. That's coming up. So far, we've only been talking for about 10 minutes, or maybe 15 minutes if you're very long-winded like I am, right? So this is all just an introduction to the activity, which is coming right now. So thank you for that segue. No, it's great. Because by the time you're thinking about, hey, are we actually going to do something? Guess what? We're going to do something.
Because on a dome, I'm sure this looks amazing, but I don't have that.
No, that's fine. And so what I've done is in the chat, I've put a link to 2 Google Docs. One is all the flat media I used, and 2 is the actual kind of the sample script. Now, if you're not sure about what to do with a script, it's not a script in the sense that you're supposed to read it verbatim. That's kind of never the point of my content. It's just a guide and an example of what you could say to somebody. Because in all of my programs, I really try and prioritize people's questions, asking people questions, and just the whole interaction. I really shouldn't be lecturing as long as I'm lecturing here, because this is a training. It's not an actual it's not actually me delivering the show. Does that, hopefully that makes sense. If it doesn't, we can talk later. Yeah. All right. So, so hopefully you're taking a look at that. If I were following my own slide deck, I would be on slides 23 all the way to 36. 23 to 36. So that's all the different slides that you see all around the dome right now. All right. And again, take your time to look through it. If you just mute me and just look through it yourself, that's totally fine. Come back and ask a question when you have a question. All right. But I'm going to move on now. So, because I did want to kind of stop in about 15-ish minutes. And so you can see I have them rotate around. And again, this is just a nice time for the audience to relax and take it all in, because we've done a lot at Mars over the last just even 60 years. All right. So of course, in the planetarium, we like flying. So we're going to fly to Mars in a planetarium. And if anyone uses eyes on the solar system, you can fly to Mars in a flat screen too. No problem.
I just scrolled up to see what Nick Strobel wrote. Very funny. You should know that. He says, so song and dance is optional.
Yeah, song and dance is optional. Absolutely. Okay. So this, if you're not sure, if you haven't seen this before, please go check it out. It is the 360-degree video from Perseverance, a real one. And the sound you just heard, hopefully you heard it, maybe you didn't, is the real wind of Mars. So we have those now. So please use them in your programs. I'm super proud of it.
We did hear the sound.
Okay, good. Yeah. So there is actual wind sound from Mars now that you can play in your programs and say, this is what Mars actually sounds like. Before Perseverance, we did not have a working microphone on Mars. So Perseverance brought the first working microphone on Mars. And so I think I should pause it right here. I did pause it. Okay. So here's the activity, right? So you've talked for like 10-ish minutes, 10 to 15 minutes about the history of the art of Mars at this point. At this point, you say, well, here we are, we're sitting on Mars, and we're going to do this very classic art activity. We're just going to do sketching. We're going to sketch the landscape. You're going to sketch what you see. As you see this, you see art students do this all the time, where they're out and about with their sketch pads, and just part of their class just sitting there and sketching things. The twist, of course, is that we're going to do it on Mars, everybody. So you hand out a piece of paper and pencil to everybody, crayons, markers, whatever you have in your dome is great. And I've actually designed it so at the Lawrence Hall of Science, we actually had lighted clipboards that you could give out to people in the dark, so they could actually draw and sketch in the dark. And on the resources section of the show page that I've made, there is a link to instructions on how to make those. But I also designed it so that by the time you get to this activity, you're sitting on Mars with the real Martian lighting. So the sky is actually fake, but it's from the real data. So they took pictures from some of the sky. So I actually just took those little bits of sky and I extended them to cover the entire dome. So it's based on real data, but the sky is simulated, is the term, simulated. Okay, but the lighting is real, the landscape is real, the rover that you're seeing is real. And if you're on the flat presentation, you're on slide number 38 now, 38 through what, 45-ish, 38 through 45 if you're following along. And so here we would just sit down and spend some time and give the kids and the parents some time to just look at it and do that classic art activity and just sketch what you see. I'll be perfectly honest. I feel like I can be honest with Alan after all these years. But when I first heard about this activity, I thought it was going to be like a real bomb in the dome. I thought nobody was going to want to do this. And I will tell you that I was super, super, super wrong. Absolutely everyone that I've ever done this show for absolutely just loves just having the time to sit down, appreciate the beauty of Mars. And well, they weren't sketching Mars in that activity, but they were sketching something else. But they just love just sketching. It's just they just love drawing. It's something. There's something I personally like, and I've done this activity myself with other people, and I think it's just something that not a lot of people get to do in their everyday lives, even though it's something that everyone has the capability to do, right? And just providing that twist of, hey, let's do it on Mars. Let's do it while we're sitting surrounded by the landscape of Mars. I hope is really compelling for you as a presenter and as an educator. And of course, all around, you'll see that I've chosen just a couple of things. If people don't feel like sketching the literal landscape, I've provided a couple of things where they can actually pull some more inspiration for their sketches. And this is actually from a real NASA activity. It's called Art and the Cosmic Connection. If you've never heard of it, you can go check it out. Again, links are in the presentation. And if you feel like doing it now, you can do it too. It's totally fine. If you feel like, for example, you'd like to take a pencil out and sketch one of those images, it's interesting to try it out, because we don't need more pictures. We have plenty of pictures. But when you're sketching, it really brings out what interests you personally. What is interesting about this picture to you? What are you focusing on? What are you highlighting when you're sketching? Because it all comes from you when you're sketching it. So it's a really good introspection tool as well. Thing about the Art and the Cosmic Connection, I'm hoping people have done it before. If you haven't done it, again, I put the link in the chat. Please go check it out. That's the original. That's kind of the original version, and they actually do way more than just Mars. They do Earth, and they do the Moon, and they do a whole bunch of other things. But so these slides, so I'm showing now on the dome, kind of those slides, kind of almost taken verbatim. You can actually use these sketches for something real, right? So it's not just something fun. Sketches still have scientific value, because again, it draws your eye, it draws your focus to specific features, and all these features, they actually mean something, scientifically speaking. And so that's just a little thing you can mention of your sketches actually have value. And this next video, I just pulled, literally, it came out this month, of just the most recent example of how art influences the science of Mars. So I'm going to play that it only plays for about a minute.
Now, detailed images from the orbiter are helping scientists better understand Martian winds. Leslie Tampery is MRO's Deputy Project Scientist. Leslie, what are we seeing in these images?
So what you can see here are dark patches on the surface of the ice near the South Polar region. And they're created by gas jets that come from under that ice up through cracks and deliver that dust out onto the ice. And the wind will carry that dust and lay it on the surface, forming these fans. And what we can do with this information is we can look at the directions and the sizes, and we can try to understand what the wind field is doing.
And I understand that volunteers played a large role in this research.
Yes, they did. We have taken about 75,000 images over all of Mars with our MRO high-rise camera. We used citizen scientists, 80,000 volunteers, to map these fans and map their directions and sizes.
This is actually a good spot to put in my email address in case nobody has it. If you want any of the links and whatever, or if you have any questions later, just ask. All right. All right. So this is actually pretty much the end. The last thing I'm gonna do is I'm just gonna do a really quick blast out. And there's of course, if anyone's heard of Holtz the Planets, there's a little snippet of that in there as well that you can play. And if you're on the flat media, let me just double check. If you're on the flat media, I am now all the way down to slide number 63, all the way down to slide number 63. I mean, there's a lot of, you can tell that if you did this in a flat media, you'd have to figure out some way other than putting just one picture per slide. So for me, I just blasted them all on the dome, because it's really fun to do that and let people see different things at different times, I think. And again, this is just a time for you to close out the activity and say, look at all this art of Mars, because even today, art is so important. And I want to say art is important in science, but again, the whole point of this is that art and science are really part and parcel of the entire human endeavor of exploration. Science inspires art, art helps science, so many people think that they're separate. I'm sure most people have heard the myth of like left brain versus right brain, or like logic versus creative. That's a total myth, in case you didn't know. Nobody is just creative, nobody is just scientific. You're human. You think about all these things as in an integrated way. You might prefer drawing over chem labs. You might prefer music over graphs, but the idea is that it's all part and parcel of the human experience. So that's kind of the point of this show, is that you want to integrate them, and I think planetariums especially are a great way to do that. Okay, okay, so that's kind of the first half, and I'm actually going to just run through the second half of the show pretty quickly, because technically speaking, I made this as one kind of standalone activity, but the other one is very simple. I'm just going to kind of fast forward a little bit, because the other one is about astrobiology. And same thing, we're just going to do some art around astrobiology. We start the show by showing all the stars and saying, well, does anybody think that there's life out in space? Does anyone not think there's life out in space? Is anyone not sure? I want people to think, well, what if there is life out there? What kind of life would it be? And using your creativity to imagine that is the point of the second half of this show. And so I kind of show people, well, what would happen if I showed you all the different stars in the sky? So that's kind of, I'm going to pause right there. That's kind of me bumping the stars up to 11, basically, and kind of showing people that the stars that you see in the night sky, they're a tiny, minuscule, infinitesimal amount of the actual number of stars out there, each of which have planets. And so that's just to get people thinking about, well, there's way more out there than I thought there was. So what are the possibilities of life out there? And to introduce astrobiology by looking at our planet Earth, the only place we know of that has life, and talking about how astrobiologists start by looking at the life here on Earth and asking very, very important questions about it. So I'm going to pause that right there. So I've just picked up a bunch of different pictures of life. You can pick whichever ones you want. If you're on the flat media, if you're following along on the flat media, I am now all the way down to slide 82 to slide 98, if you're counting. But the idea is that astrobiologists ask these really important questions of what is life? How do you define life? How does life adapt to different environments? How and what exactly does life need? And because that is really what we're talking about when we're talking about astrobiology. Fast forward a little bit. So here I just picked some random pictures of what does life need, and the consensus in astrobiology today is that life really needs just two things. Life needs energy, and life needs liquid water, or at least our type of life needs liquid water. The point to make is that we can certainly imagine alien life that doesn't need any of those things. But if we're looking for things that we could recognize as life, we kind of have to start somewhere. So again, astrobiology is all about, this is just a start to our hunt for life out there. Because if we look at our sun, for example, that's what we're seeing here. I'm flying to our sun. I'm going to fast forward a little bit. So we're flying to our sun. This is kind of too close for liquid water. And if we fly too far, that's too far for liquid water. So there's the habitable zone, and you can talk about the habitable zone and how there's this perfect place, this Goldilocks zone, that's just right. And what's really, really fun is that you can actually show, well, which planet is right in the middle of the habitable zone. It's Earth. And we can actually find these other exoplanets that are in that perfect place, that perfect habitable zone for life. One of my favorite ones, I've picked 3 of my favorite ones just to kind of showcase what we're talking about. Kepler 22b. So we're flying to Kepler 22b now. Shout out for Kepler missions. And this is actually a texture that I grabbed from one of the NASA sites. And all the sources are listed there. So Kepler 22b is a giant super Earth. We think it's a water world. And so what kind of animal could live on Kepler 22b, where it has really high gravity, where it's pretty warm, and it's covered in ocean? What kind of animal would live there? And one person imagined something that looks like this. So if you're following along on the flat media, it is slide number 105. This is the dweller octopod. It's enormous. If you take a look, there are little dots that it's about to eat. Those are supposed to be the size of whales. And the concept is, what kind of animal would thrive in these certain environments? So, for example, we talked about, before I had a picture of a blue whale, why are blue whales the largest animals in the world, on Earth? Why are they in the ocean? And why are they not on land? Could they survive on land? And then if we just keep going, the next one is Kepler 62f. Kepler 62f is really cold, but it's also a super Earth. And we think it's covered in ice, but one study said that if it were tidally locked to its star, if it showed the same side of the planet to the star all the time, that side of the planet would actually be a little bit melted, and it would actually be able to support some form of liquid water on its surface. And so what kind of animal could live on a frozen world where there's only one section of the planet that actually could have liquid water? Well, it could be the gigantopede. The gigantopede is a pretty large but not super large animal, and it has all these strong, thick legs, and its eyes can pop out and retract to protect it from the super cold, and it can actually roll itself up into a ball to keep and preserve its body temperature. I'm just going to zip through the rest of these. And of course, TRAPPIST-1, I chose TRAPPIST-1D. So that, again, that's just a texture that I grabbed from the NASA site. So we're going to land on TRAPPIST-1D. And that's an actual NASA 360 of the surface of what we think the surface of TRAPPIST-1D might look like. The research has been updated since that came out, but still I like using it. And so this is the gliding hopperoo. The gliding hopperoo has really thin legs, because guess what? TRAPPIST-1D is tiny, tiny, tiny. It's a tiny planet with very, very low gravity. So it doesn't need strong, thick legs. And it's really hot. TRAPPIST-1D is just on the inner edge of that habitable zone. In fact, some calculations have it outside the habitable zone. So the gliding hopperoo has these gigantic wings. It's full of blood veins that can help cool off. The song and dance, again, is optional, how much song and dance you do. But ultimately, we're going to go back to Mars. And we actually have multiple Mars 360s. So if you want to use a different one, for example, if you're doing it all together and you want to use a different Mars 360, you can. And then we can mention about how Perseverance is the astrobiologist on Mars right now. So Curiosity and all the Viking ones, they were rudimentary in their skills to detect life. But Perseverance, its job, its primary purpose was to look for signs of ancient life. And this is an animation that I grabbed from the Science Visualization Studio. That kind of shows the evolution of Mars. So the idea is that once you're on Mars, you want people to imagine, there's epic music here, but I'm not going to play it for you. You can imagine what was Mars like 4 billion years ago. Because 4 billion years ago, Mars was wet. We know this now. We know Mars used to have water. So what did it used to look like? And so this is just a nice little animation that I grabbed. I actually reversed it too, because the original animation went from 4 billion years to today. In this one, we're going from today to 4 billion years ago, because the idea is that I want my audience to think, well, if we travel back in time, we know that Mars doesn't have any life today. We haven't found any life on Mars today, but it could have had life in the past. So what could that look like? What could a wet Mars look like? And what kind of animal would live on a wet Mars? Yeah, and I even added some water sounds just to make it a little more epic. And then this is again where you bring out your sketch pad and you say, well, now that you've had all these different examples, we went to Kepler 22b, we went to Kepler 62f, we went to TRAPPIST-1d, and now we're back in ancient Mars. And these are just a couple more examples of other things that people have come up with. So Alan will notice that I did grab the original astrobiology images from Red Planet Mars, and I put them in here as inspiration. And these are just, again, you keep this up and you give people 5 to 10 minutes to sketch what they think an ancient Mars alien would look like. Remember, Mars has low gravity. Remember, it's very, very cold. Even though it looks like a desert, it's very, very cold. So what kind of animal would you draw? And so that's kind of the activity. And then the last thing I want to show people.
Jeff,
go ahead.
I just want to comment that those black and white drawings that you have there.
Yes.
Those are actual kids' drawings from an activity that, it was like a classroom activity that went along with the Red Planet Mars. And those were drawings that kids did.
Yeah. So like I said, people love doing this. It's really, really fun. And so I just want to fast forward to the end. So again, you just do this for 5 to 10 minutes, or as long as you want, really, as long as you want. Just let people sketch as long as you have. And the last thing I show people is this one. This is the first Mars core. We took it literally a few weeks ago from the delta itself. That picture right there is why we went to Jezero Crater in the first place. And if there ever was any life on Mars, and especially where we're looking for microbial life, of course, if there was ever any life on Mars, it could be in that little teeny picture. You could be looking at it, literally right now, you could be looking at it. And we won't know until we get it back, but it's exciting to end with this and to say, okay, we know that we're not going to look for, flying monkeys on Mars. Okay, that's no flying monkey bones are going to fit in there. But if there was any life at all, there would be microbial life. And if it were anywhere on the planet, like this is why we went to Jezero Crater, because if there was anywhere on the planet, we think could be there. So that little picture right there could change the history of humanity as we know it. And what I always love to end with is that the kids in your programs today, they will be the ones to grow up and discover these things, right? So it's not something, esoteric and not something that will never happen. It's happening now, right? That rock sample is in the belly of the rover, and it won't be back for, 10, 15 years. So if you have a 10-year-old in your show right now, in 10, 15 years, they'll have a PhD and they could be on the team that open these up and find signs of ancient Martian life. So it's an exciting thing to think about whenever you're teaching. It's what gets me up in the morning when I'm teaching kids. So I always like to end with that. And a quick shout out to the Bishop Museum in Hawaii. This is a frame from one of their NASA shows that they've produced. So thanks to the Bishop for that.
Hey, Jeff, it's Roseanne again. I just posted in the chat spaceplace.nasa, you know, for the coloring pages, because you just brought up something. If it's a 10-year-old, this is one thing, but they could then, the parents can print those 120 pages and the kids could go at it with all kinds of things. So I just wanted to say, I just posted that for you.
Thank you very much. Yeah. So NASA does all sorts of, NASA does loves art. You know, we hire artists. We absolutely hire artists. We absolutely hire writers. We absolutely hire chefs. A lot of people don't know that NASA hires chefs. We do. You know, we hire musicians. We hire video game designers. That eyes on the solar system that somebody posted, guess who made that? It wasn't me. It wasn't a Martian scientist. It was a video game designer that we hired to design that, to make it interesting. Again, it's all part and parcel of the human experience. The creativity and the logic, they all go together. They inform one another. They help one another. They advance civilization together. It's all integrated. So that's kind of the last thing I want to end with people. And I'd be interested to hear your thoughts, interested to hear how you would change it, how you would adapt it for your purposes. If you have any questions about adapting it, if you have any questions about executing any of the activities, I'd love to hear that now.
And one person who came in late, Jeff, asked a question about where can you get this program? So you might want to review that. Maybe put the link again in the chat if you don't mind. Would that be?
Yeah, absolutely.
Okay, well, while you're doing that, there's a question of what would the length of this program be? 60 minutes, less? I want to comment on that, in that the original Red Planet show, which was inspirational to Jeff, but it's different, was designed to be a 50-minute program. I think, if I'm not mistaken, Jeff, you've made this into 2 short programs.
Yeah, and I will say that I never, ever was able to do Red Planet Mars in 50 minutes. People just love drawing too much, right? I felt it was like tearing out my soul, making this kid stop drawing his alien. So I always went over, always. So I would say if you're going to do the whole thing, you could do it in 60 minutes. You could do it in 60 minutes, but yeah. So I split it in half. So the first half is 30 minutes, and the second half is 30 minutes. So the kind of sketching Mars activity, I would allot at least 30 minutes. Again, you could let them draw for as long as you want. You could make it a whole summer series if you wanted, right? And the astrobiology section, again, you could do it in 30 minutes if you really had to. But could I do it in less than 30 minutes?
It's possible. It's possible.
Sure.
Some people could do that. And I have to say, from my own experience doing the show way back when, the kids enjoyed drawing more than the adults. It's harder for the adults to get into that, but they do.
Yeah, well, the tip for that one, I do have a tip for that, and that's to hopefully whenever you get an adult in your show, hopefully they came with a kid. And the secret there is to get them to work together. So to really get the adult invested in doing the activity with the kid. And of course, I have had adult only shows, and in that case, the trick is just to make sure you're as open and non-judgmental as possible. For example, there is an option in the script, in the coding that I created, there is an option to share on the dome what people have created, right? So you ask people to volunteer your artwork, and you show it on the dome. That's possible these days. And for adults who seem reluctant to do it, I've always found that it's because they're worried about judgment of their artwork. Like they'll say, "Oh, I'm not that good of an artist," and the important thing for that is that it's just for you. It's an expression of your own creativity. It's something to help your own creative juices flow. And so framing it in a way where it's non-judgmental, you don't have to share it if you don't want to. It can be just for you. Can help, I think. So again, if you have the Google Slides, there is no PowerPoint, it's just a Google Slides. So if you don't know how to download it, you just go to File and Download, and it should download as whatever you want.
I have a comment about the logistics of any drawing activity.
Mhm.
And it has to do with even reading something on a piece of paper. A lighted clipboard is a very nice, elegant way to go, but it means every seat has to have a clipboard, which is a challenge. What we did originally in our the Holt Planetarium way back in the 70s was what we called cove lights are not what I had no understanding of what cove lights are, and because in our planetarium the cove lights pointed down, they were actually reading lights. And they were orange. We found that the orange color was the best color for reading rather than red lights. It's totally different from amateur astronomers who don't want to destroy their night vision, and so they use red light. But in the planetarium, orange light actually worked the best as a compromise between being able to read okay, especially old people like me being able to read, and still being able to see the sky actually to some extent. So if you sometimes it's a balance in illumination of the room. If you don't have clipboards, you can balance the illumination of the room so people can actually see what's in front of them in their lap and see the slides. Okay, that's not that hard to do actually, especially when you have bright slides.
Yeah, actually, I think it's funny that you mentioned that, Alan, because when I went to my first planetarium conference and people were talking about cove lights, I'm like, why are cove lights pointing up?
That's industry standard, Jeff.
I didn't know. But yeah, so to go off on what Alan said, so one of the reasons why I chose the Mars 360 was because if you use that, in theory at least, depends on how your dome is all set up and whatever, but in theory, the orange-ish sky of Mars, it could be enough where you don't have to go through the whole process of like figuring out how to light your seats and figuring out how people are going to do it. So you'll have to test that out in your own dome, of course, and figure out what makes the best lighting solution for you. But it certainly is possible, and it's a lot of fun. And I will say that the lighted clipboards that Alan, you made them, or you and your students made them, they were one of the most popular features of the dome. I mean, like forget the actual dome. People just love turning on and off the lighted clipboards.
Well, the best clipboard, the best design now is the ones that John Erickson made most recently. Yeah.
Do they still make that nice clicky sound? It's very satisfying.
Yeah, it's like a standard wall switch that he used. That is the most solid, unbreakable. The early ones that we made were a little bit on the flimsy side, and they broke.
I thought they were great. Yeah. Oh, Lisa, hey, how are you doing?
Hey, Jeff.
Hey.
So it's great to see you.
Yeah, always great to see you.
Really great stuff here, and it's really interesting because of like what you shared, the last slide of the most recent one about Mars and the water. I love the storyboard you put together and all the implementation with the 360. My question is, in incorporating the photo stitching, taking the photographs and stitching them together and then implementing it into a 360. I'll follow through your notes and such, but how much time did it take you to do this?
That's a really good question. Actually, there is a very nice featurette on how JPL does that. So I created the 360 videos. I can't take credit for the 360 itself, the panorama itself, because that was all done by the science team. So they do that every now and then. They don't do that very often because it does take an enormous amount of time. And in fact, one of the main challenges is that because it takes so long, the sun will have moved, right? If anyone knows any filmmaking, you're losing the light,
Yeah.
Right? So that actually is a challenge for the science team. But they have done if I were to think off the top of my head, I would say like a dozen or two, on the order of a dozen or two 360 panoramas. And when I say 360, it doesn't always, it almost never includes the sky, right? Which is what
Yeah.
planetarians really care about. But they,
Right.
I've asked, and they're like, no, we don't
Yeah.
want to take. There's nothing interesting up there. Well,
Right.
we're not going to waste our time and bandwidth taking a picture of a blank sky. And I'm like, okay, fine. So yeah, so when I made the 360, I had to extrapolate the sky from the bits that they did have. Yeah.
Okay.
So,
So
but I will include that for that little featurette. There's a really nice one that the JPL made, all about how they get those 360s.
okay, great. Because I'm doing the 360s and then incorporating the interviews from, the James Webb Space Telescope first images
Hmm.
and content to incorporate with all of this. And I really wanted to do one with Mars and the Perseverance rover and Ingenuity helicopter as well, which
Hmm.
I have content for. So this is a really great storyboard because someone just asked me yesterday, do you have any time to do something like an activity before the students go back to school?
Yeah.
And this is perfect timing.
Yeah.
Thank you.
I'll reiterate that when I first heard about this activity and Alan was telling me, oh, this is what you're gonna have to do with the kids. You're gonna have to get them to, you have to make them draw. And I'm like, what, really? That sounds so silly and not, but no,
No.
they love doing it.
What?
And if you have a different experience, if anyone does have a different experience than that, and you do have difficulties, please let me know so I can stop telling people that story.
No. Actually, what I did is the same exact poster that you shared and what's in your presentation. I have the poster, and for the first images event on July 12th, at our host event, I taped it to the wall, had everyone think and experience what they experience, what the universe looks like. So they all took, pencils, crayons, whatever, adults, even children, before they saw the first images. After they completely saw the images and all photographs were taken, they went back to their image of drawing the universe. And it was amazing to see the students have whirlpool galaxies, stars, all sorts of things. It was completely fascinating.
That actually is a really great idea. I think if you wanted to do if you wanted to start the program by saying, draw what you think Mars looks like. What do you imagine Mars looks like before I show you any pictures? I think that's a great extension activity. I think that's great. I'm gonna add that in. Thank you, Lisa.
Okay, so
Thank
we have
you.
there's a somebody with their hand up, Sarah Taylor. You want to unmute?
Hey, I had a follow-up activity that I've done that I think would work really well for some people with this with like this activity, especially the Mars sketching. Is that if anyone's ever seen Galileo's moon sketches, those were done. If you look at what the magnification of his telescope, because it was so long ago, it's about the equivalent of modern day like higher end binoculars. And so you can basically copy Galileo's sketches at home. And that would be, I think, a great take-home activity for people. Once they've done this, seen the show, they could, maybe you could print off like a half page of like some examples of the sketches and like say, here, go home and, try this yourself. All you really need is a pair of like decent binoculars, or even like a kid's telescope is enough power magnification to see pretty much what Galileo saw in those really famous sketches. So I really like that activity. And then also, I saw some of them in one of the dome pictures. NASA's Exoplanet Travel Bureau posters. Those are great to use for whatever you're talking about astrobiology, or like exploring other planets, or like thinking about what it would look like on other planets. Those are great, like jumping off points for people. So I use those at all activities when I do it. If I'm doing like an in-person activity, or even in Zoom, I'll hang them up behind myself sometimes so people can see them when I'm talking about stuff like this.
Absolutely. Thank you, Sarah. In fact, that reminds me, I should probably include So first of all, the Galileo activity, excellent idea. I'm going to put that in too. Thank you. And I do have my own little slideshow of just all the art that I personally like.
Jeff, this is the perfect time to say it's STEAM, not STEM.
Yes.
And so
STEAM.
many schools are actually changing their building names where they're referring to this. And as you know, I mean, this has been my number one for all these decades. And I think this is something we educators in all sources need to say. It's STEAM, and make that A really large, because I always say, of course, do you think the engineers work out in the parking lot, or do they work in a building? Do they
Architects, that's right. Yeah, architects.
Okay.
Exactly.
You know where that comes from.
Yeah,
Okay.
absolutely.
Thank you. This has been absolutely fantastic. And I sent you an email with something that's very funny that you might want to pull that up and just show it now, because it fits. Did you see it?
I'm not on my work computer. Did I mention that today's my day off? I'm doing this.
Right.
Yeah, I'm not on my work computer,
If
but I will check it as soon as I.
Because it's so, well, just everybody. It's a very funny. It's a man sketching a drawbridge, because in front of the sign that says drawbridge ahead. Get it? So the humor, I think, that we throw in whenever we're doing these things always gets everybody excited. Alan, I'm sure Jeff will send it to you and then you can send it out. It's just too funny.
Okay, thanks, Roseanne.
You're welcome.
And again, I don't want to keep anybody. If you have to go, please do. If you don't have anything more you want to ask or anything, please feel free. Thanks for coming, and have a wonderful rest of your day. If you need to go.
There's been a lot of good links and comments in the chat, and I always post the chat along with the recording.
Yeah, so I've got some good notes here. Thanks, everybody.